two, one. Hi everyone, welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, BH Moon, who has completed our course, ROS 2 Navigation, in 5 days. And at the end of this course, there is a project that you can present in order to show what you've learned and implement autonomous navigation on a real robot here at the Construct. So that is what we will be seeing today from our students. So hi BH, how are you?
How are you, Rodrigo? How are you,
I'm
everyone here?
I'm good. I'm well. I'm excited to see what you've done with your project. So whenever you want, you can start sharing your screen and get started with the project.
Okay, let me share my screen.
Great.
Okay, so can you see my screen now?
Yes, we can see a lot of we can see
Okay,
the presentation now. Awesome.
so this is a BH Moon. Uh, Today I'm going to show the live demo, sending the robot to the pre-defined positions.
Okay.
And because of the sometimes this is not stable, so I made a recording for the other task like mapping or save spots in couple of the other way. And I'm going to show the video, but I'll try the real live demo if there's a request. And also we're going to review the code briefly, and then we'll go to the question and answers.
Awesome.
Before going to the live, thank you. Before going to live demo, I'm going to show you what is our objective. There's a 3 point we're interested. There's a corner one and the corner two, and then pedestrians. So that this is the coordinate of the map. So that robot start from the red spots here. There's 0.0, which is starting point, and then going left and top is become the positive values, so that the corner one will be minus x minus negative y. So here it's around 0.62 and 0.13 minus values. And then point two will be the plus some values. And then the pedestrian will be right above the center point. So
Okay.
this is the simulation location. However, if you see the RIBIS map, Albi's map, so we will see the same thing. So that starting point here, and then there's a corner values which is captured in the YAM file.
Uh-huh.
Okay, so this is the location I'm going to send. So that let's go to the live demo. So that here actually layout this way. So then let's go one by one. So I'm going to go to the bridge first. So let me copy and paste because to save any mistake. Okay, so that the
Good
bridge
idea.
start like this.
Love your layout.
Right, and then okay, and then I'll go to the second step of bridge. Okay, and then everything is coming up like TF messages, everything is coming up,
Mm-hmm.
sensor messages. So while we are waiting for this, everything comes up. I'm gonna turn on the Alvis 2. Okay, I'm gonna put them here so that we can compare uh, Alvis versus the real robot. Okay.
Oh, that's great.
So at the beginning, I'm going to use the. Any questions?
No, I'm just making comments. Sorry.
Okay,
I
so
love
that
it. I
I'm
love your
gonna show
layout.
you.
How you can see our
I'm gonna
bridge,
show
everything.
you start from the the initial point first, and then now I'm gonna start AMCL, which is the localizing where's the robot. So let
Uh-huh.
me open this file so that this. I'm sorry. This is the right. This is the localization launch file. So I will go to that. The localization is here. So that there is a localization and launch file. I made a localization launch file with this. And then launch it. And now, oh, maybe something not here, but they're asking to, they were supposed to asking for, the positions to start the initial points. I'm going to do that. So right now, the robot is almost same as the guidance and the tutorial.
All
Then
right.
now, so I'm going to turn this robot so that they can converge the cloud point. Let me rotate them. Right, so it's going well.
Uh-huh.
The point is converging into the smaller. Okay, now it's good.
That's good enough, yes.
And then I'm going to. Oh my God, I put the wrong point here. So let's put the path planning here
All
so
right,
that
we'll
I
switch it.
will copy paste command. Give me a second. Okay, path planning. So I was using two different the how to call that managers, so that there's AMCL one manager, life cycle manager, and then
Uh-huh.
another life cycle manager for the task planning. So
Yeah.
after launching this, then I'm gonna update the Ravi's configuration to show the all those the cost maps. Okay.
Oh, lovely.
However, sometimes it's not working well, so I don't know why, but I will show you the my recording. But here,
I know why,
uh,
but I don't know
I
how to
don't know why,
fix
but
it.
cost map does not work. But in my simulation, it doesn't work very well. Anyhow, so I'm gonna go to the code pose the command so that I already give me a second. Right. So okay, I'm going to send predefined position. So the predefined position is here. So that there's a go to pose coding here. I made a very messy coding. I don't think it's the best way, but maybe it's the best I can do. And then
Hey,
they have a
that's okay.
predefined this coordinate, corner one to pedestrians. So I will show you how to save this one later. Let me send them first. Okay, send them. Oh my God. Okay, this should be ROS.
And where is the robot going? What is corner one? Where is that in the map?
Corner one is the bottom left side.
All right.
Yeah, like okay, let it go. All right. Okay. Uh, yeah, goal accepted now. And then they are creating this the pass,
Yeah, I can see it.
and
It looks
then
like
this is not
the
going
BT Navigator died. So try launching path planning again.
again, right? Okay, let me do it again so
That's
that I kill it and then pass finding again.
and I think the bridge is still working, right? Yes, otherwise we wouldn't see the scan. Yeah.
Yeah, bridge is working. Okay, so let me send the command again so that corner one.
There we
Right. Oh,
go.
it's working now. Okay, right.
There we go. It's
Sometimes it's
just
not working, sometimes it's working.
yeah, I have a feeling it's a connection issue, but
Yeah, maybe, yeah.
it's
So
difficult.
here, the unfortunately, I cannot see the cost map very well, but if something is going moving on the background, but the cost map is working well. But the
Yes,
display something.
otherwise it
Hmm,
wouldn't work. This is a visualization error. It's known because of our
right, right,
connection.
right.
Sometimes it
So
shows up, sometimes it doesn't.
hmm, let me send it to the corner two, and then okay, let's do it again. Okay, they make a global map is making path, and then they're following this route very well now. Okay.
Awesome.
Oh my God, he's changing. Okay, he's changing. Right.
Oh, it fixed
Okay.
itself. That's
Right. Okay.
nice.
Oh my God, what he have to? Oh my God, he didn't see that. Or you know. So the local cost map is not working. I don't know.
Well,
Oh
this could be
oh
a lot of different reasons. But yes, it seems like the local cost map didn't catch that.
Right.
Let's
So
try
let
another
me
one.
send you. Yeah, yeah, yeah. Pe,
Yeah, the
let's say, oh yeah,
pedestrian should be easy.
pedestrian. Okay, pedestrian. Okay, they set the pass and then they are moving.
Uh-huh.
Right. So this was the final objective of this quiz. And then
Awesome.
I'll go back to PPT again. Okay, here. So the first, the quiz was we save the spots by manually, so that when you subscribe, the AMCL after full navigation started, so we can subscribe this topic so that they can sending out these position values, and then maybe I can drag and copy and paste on the file. This is the
Mm-hmm.
manual way. The second way is create a service that can save those paths into files, so that I create one file which is spot recorder, the node name, and then they actually create service which is a spot save spot services.
A service server, yes.
Yeah, and then you can see, if you see the list after activate, you can see the save spot working. And
Mm-hmm.
then I move the robot to the certain location and then save the file. I'll show the video about it. Okay, and then um, save spot by manual moving. Okay, let's move this one.
And this is how you saved the corner 1, corner 2, and pedestrian,
This right?
correct?
I don't know. This is the second way. Actually, the last way I will show you.
Uh-huh.
Just the two other way.
Oh, you got
So
three
I just
ways. Nice.
yeah. Actually, in the your tutorial, there are three ways to
Oh,
save the file.
okay.
Right. So there's okay, now the bridge is working, and then Alvis is working, and then the localize started, right? And then I move the robot to certain positions, and then activate this spot, save spot, this service server. Okay, and there this server is activated,
Huh.
and then uh, I move the robot to the desired location, like corner one, and I type this, I call this service. So here you can see, I'm sorry, the type is not clear, but
Uh-huh. No, I see
service
it. I see
call,
it. Save
right, and then the
spot.
corner one, and then they are saving these locations. And after that, I move to another location. I'm gonna move faster, and then saving corner two, right, and
Mm-hmm.
then go to the last point, and the pedestrian saving. After that, the last point is the end. So that if you type end, it was supposed to create a file. Okay, at the
Oh,
end
I
of
saw it
the
created. Yeah, yeah.
yeah, you can see this was created, right? So the
Yeah, right
control
away when
behind
you
this,
when you hit end, there you go.
right? And then you see this is created. This is one of the ways, so that we manually move the robot certain place and then save the file by subscribing spot save spot service client. The
Mm-hmm.
other one is initial pause. So that this is another way to save the positions. So here bridge is working again, and then so in this case, I don't have to move robot at all. So that I just activated the map server, and then map server already have all the coordinate, and then I'm
Of course.
subscribing
Yeah.
the initial pose only. So that I'm going to show that initial pose is echo now, and then activate this 2D pose the I'm sorry, this client coding. I'm sorry, coding this coding. I just run this coding, and then I locate 3 points in one by one, and then they're updating this location one by one, and then creating some file object. Let's see now.
All right.
Right. So that when they echo, this also supposed to show this new value, but I don't know, maybe it sometimes works, sometimes not working. So unfortunately, when I recording this one, it was not working, but it is working actually. I'm saving the last 3 point, and you see there is a spot YAM file is created. Before that,
Yeah, yeah.
uh, no file, and then after 3 point, the file is created. Right, this is the you know the file saving in the YAML file, and then I'm using this file to the code to pose as a predefined location,
Right.
right?
So then
So I just explain.
so then just to understand this, um, the way you're doing this is you're putting those spots and positions into a file, and then within another node, you're looking at that file and sending a goal post to those.
Right, right,
All right.
right. So let's go back to the code to pose. Okay, so this code to pose is the so that actually we subscribe, we're sending goal to this action server. This action server navigate to poses action server, and then we are sending goal to from the terminal, and then sending goal to the navigate pose by this YAML file, calling YAML files.
Uh-huh.
And during this time, they are calling spot list here one by one and go there. Right.
And then,
This is the first video, the live video I show you.
yes. So then how do you call those? How do you call this go to post? Is this a service server or what is it? You just,
Okay, when you have full navigation working,
uh-huh.
so that you can see there is a navigate to pose action servers. I can show you that there's a ROS2 action list, and then
Yeah.
you'll see there's a navigate to pose the action service is working already by this path planning. Okay, so
Okay,
that
I see.
we are sending goal to this action server so that they are sending robot to the defined positions.
Okay, okay. I see.
And then let's go to the coding. So that coding here, I had this is actually mapping, the planning is all following the tutorials. So that is very straightforward. And then there's a spot recording server codings. Like I have a spot to file with a text file, and then you can see there's a AMCL subscribe
Huh.
and a save file in this format to you know, the text format, and also can change it to the YAML format by this
Awesome.
way. Right. Right. And then go back to presentation. So there was a couple of things I have to slightly change it from tutorials.
Okay.
So ROS to service call, the record spot, I think it's a typo. It was supposed to be save spot from the tutorial. And then in the middle, there was supposed to be service type information so that this is a service call, service name, and then we're missing a service type, so the custom interface. So I have to create this service interface manually, and then
Yes,
after
you're
that, it's
correct.
working. Otherwise, it's not working at all. This one doesn't work.
You're
Yeah, the other
correct.
one is also when I call this go to pause, so I have to call YAML file, and then in the tutorial that there's no pass of the file, but
No absolute
it
path.
doesn't work. So then I change it to the full the pass so that I can call it without failing.
Yeah,
The other one
this
was
would work. The above one would work if
I
you
didn't
were to
it's
run
not
it,
working for me.
if you run it in the same path. Like if you
Uh,
go to src nav2 project config spot lists and then run the command above, that would work. But yes, yes, you're correct that
Right.
you would need to do
And then
that.
also I also study from the forums so that the Kirishi help us to
Yeah, our
how to
teacher
solve these
assistant.
the errors, right?
Yeah.
And then
Yes,
and then
that's a hardware issue sometimes. That in this case, the loop is going way too fast. So
right.
bringing it down helps it.
Mm, mm. The other one was when I work on the simulation, the bridge was not working sometimes, and not always, as always. When I execute first two lines, the process stopped here, so it doesn't move at all. And then I have to do it again. So if I do it, kill them and then do it again, and it works. And
Let me
also,
ask
if
you
I put
something.
this,
Sorry, I'm interrupting
mm,
you. Is that okay?
yeah, sure, yeah,
Uh, Let me ask you something. When you launched that on the left, did you have the simulation launched as well?
yeah, simulation.
Oh, then that's strange. Um,
Right. So I have to stop this and then Control Z and then run again, and it works. I don't know
mhm.
why.
The bridge is
And the other
famously
one,
unstable. Yes.
maybe some bridge issues. So, and then it was working well in the robot, actual robot.
Okay, that's good
Yeah.
to know.
The other one was the last line. So when I use this one, doesn't work. But if I remove this
Oh, yeah, that's a
last,
mistake as well. It shouldn't have the last part. You're right.
mm. There's some personal story. Actually, I'm making robot myself. I like
Oh
this
my God,
one.
that's awesome. That
Right.
looks great.
And then, right, so realizing all the learning from this course, so that it was very nice course, so that I can completely utilize them in the real robot. And then you can see this is robot I'm making. They're actually moving. Is a manual moving now? But
Yeah,
I'm going
yeah.
to
Oh, wow. And that
using the
runs on
lidars.
Rust too?
Yeah, it's running on Rust now. So that
Oh, wow.
the let's say I'm sorry, the laser scan is working
Uh-huh.
well.
And it's 3D
So that
printed really nicely too, I see. That's awesome.
yeah.
And is this a differential drive robot? Because I see the
Okay, so yeah, there's some tricky way. So actually, those two wheels are driving.
ah
However,
the
if I put something, below, it's not looking good. So I was going to put some other wheels, but other wheel cannot uh, cannot accommodate two-wheel driving. So that I use a mechanical wheel. So that
yeah.
when they drive, it changes.
It looks better actually as well. So it looks
It's
really
a
nice.
stable, and then it does not interrupt any the differential operation.
Yeah, because if you were to put drive on those front wheels, it would need to be something different. So, for example, the tab local planner instead of the DWA, for example, that you used in this
Sure,
in
sure,
this.
right, right.
That's awesome. I love that. That's a
Right.
great robot.
Yeah, that's about my story. So I can go detail for the coding if you want. So
Um, I
mostly I
think
spend
based.
most of time over here. Here we go to pose. I did not know how to call information from YAML file, and this took me such a long time to find the coding for this.
Oh, so you used parameters.
Right? I don't know if this is the only way, but
No,
you
there's
can teach
many
me some
ways.
other ways to
This
do.
is a good way, yeah. So that's how you read the YAML file. So you can put, oh
Right,
yeah, the X, Y, Z, and the, okay, yeah, yeah, and
right.
then send that
This one,
to the robot.
right. And the
Awesome.
sending this one, right? Yeah.
All right. Let me ask you some questions if that's okay.
Hmm.
Do you mind stopping sharing your screen so we can
Sure.
see you? There we go. Awesome. Well, congratulations, BH. It's really, really nice project. I love that you built your own robot and your. Did you try this same packages on your robot?
No, today the only the LiDAR is working, so
Okay.
that maybe the connecting we can take more time, but I'm sure I can make it
Yeah,
soon
yeah. I
in a
mean,
couple of
you wouldn't
weeks.
need to change anything except probably the footprint and of of the robot, and that's about it.
Right.
But I love
Right.
to see that. I also love that. Really nicely done. The you how you showed us three ways to save the spots, for
Yep.
example, and yeah, these are just suggestions for us, so for an application that makes sense. Like something like that. There's just like a simple API that you can record your spots of your map and then call them from nav2 so it goes there, right? So you showed many ways to do it. You can also, for example, I'm thinking, once you make the map, you can actually go to the YALM file of the map. You know how it generates a YALM and a PGM file? Well, you can change the origin of the map to put it on the corner wherever it's like,
Sure.
re- really helpful to you, and that way you can, don't not worry so much about where the spots are because you kind of can tell. So yeah, there's many different ways. I'm glad to see that you showed those. And yes, your concerns about, for example, the local cost map and the global cost map not showing up, that's a visualization error. So I'm sure if you try the same package on your own robot locally, you will see those. Of course, if you start trying to do networking, you might run into the same issues. But what you were showing, the third challenge you had about the controller frequency, right? It being too
Right.
fast, and you had to
Right.
bring it down to 4 hertz. That might be related to the fact that the local cost map wasn't avoiding the didn't avoid that obstacle because
I see. I see.
probably it missed the control loop, and then
I
once it
see.
was it was there, it was
Okay.
like too late. But I'm not sure.
Right.
You should
Right.
and this is
Understand.
the part that always, like, at least for the nav2 things that I've done, uh, kind of drops. Sometimes the local cost map kind of drops, so you have to make sure that your config files include everything for the local cost map, and that make sure that the controller hertz is going too fast or not too slow. Of course, the fact that you implemented it remotely includes adds difficulties in this sense because the controller frequency is obviously not going to go as quick as if you were directly SSH into it. But that's what I would tell you to look at, in order to make sure that the local planning is working.
Okay.
And
Thank you. So I'll try. Okay.
and
Yeah.
just to let you know, um, you don't need it anymore. But you talked about using the bridge in the simulation. Now we
Right.
have a newer version of this project that you don't need the bridge in this case. The Turtlebot,
Right.
the Turtlebot hat, it comes in ROS 2, and so
Uh,
you don't have to worry about the bridge, which is a painful point to
okay.
worry about and to think about. And just to tell you to a suggestion for your project, is it Humble? Is your distribution Humble for that robot?
Humble, humble,
Yes?
humble.
All right, good. Because this project, I believe it was Foxy. Um,
Ah,
because I noticed, because when you showed me the action list, the available actions in your project,
right.
one of them was navigate to posts. Well, this new Humble distribution, the binaries that you install for nav2 will also
Ah,
include a action that is navigate through poses. So you can
oh
select
yeah.
a bunch of
I see.
poses, and you can also add restricted zones. You can do a bunch of different things that is already kind of provided to you by the nav2. You also can create some actions in between poses really easily within that nav2 package, new Humble distribution. So I encourage you to
Mm,
take a look at that because
okay.
it's really helpful and might achieve what you're trying to do with your own robot. And
Okay.
yeah, that's.
Great.
I mean, other
We'll
than
try.
that, BH, that was a really nice project. I love how you lay out your screen, so it's super understandable, and it also tells me that you're taking something out of our platform to organize it like this, and
Right.
and congratulations, BH, is really nice project.
Thank you so much.
All right, and
Right.
all right, that's it for me. For the rest of people watching this video, this is what you can do if you take our course for ROS2 navigation, is to literally give a robot autonomous navigation, and you can then build your own applications on top of it. So I encourage everyone that's watching to do what BH has done here, and BH, congratulations again. We hope to see you again soon for another project.
Yeah, I'll continue study and then show next presentation.
All right, awesome. Well then, that's
Right.
it for us, guys. So we'll see you guys next time for our next video at becoming a ROS developer. Bye bye, guys.
Thank you. Can I leave now?
Awesome. Yeah, we're done. Awesome.